All right, so these properties of logarithms are going to be very valuable for you if you're going on to calculus. These will make derivatives and other things a lot easier if you know and understand these. So make sure that you pay special attention to this part of section 5.3. All right, so we've got three different properties. If you take the log of a product of two things, you can split it into two different logs where they're adding together. So if you've got log of xy, assuming x and y are both positive, this is going to equal log of x plus log of y. That is our product property. You can use log, you can use ln, you can use any base you want. All right. Excuse me. The quotient property is very similar, only instead of adding, you're going to subtract. So as you see here, you take the log of u over v, that equals the log of u minus the log of v. Okay? And one of the more useful things, and one of the reasons why we use logarithms to try to extract variables from exponents, is what is the power property. So you'll notice this, let's look at the ln. ln of u to the n. We can take the n and move it in front, provided, again, that we have a product of one thing. What you can't do is you can't just take, if you have, can't do this. So ln of x, y to the z, provided they're all positive, or at least, x and y anyway, does not equal z ln of xy. So we can't do this. All right, we have to break them up first. What this would actually equal, this actually equals ln of xy to the z is equal to ln of x plus ln of y to the z, which is equal to ln of x plus z ln of y. And again, the z can be positive or negative. It doesn't matter. It's just the y and the x that can't be. All right, so let's do a couple examples here. Let me see if I can keep those up here. Let's do a couple from the book. All right, so they want us to break apart these logarithms. So number 7 on the page 383. We're just given ln of 7x, and we're asked to break it apart. So we're going to use the product property. Number 1, that equals ln of 7 plus ln of x. And that's it. Let's look at number 47. Excuse me, that was 41. I don't know where I got 7. I think I saw the 7. Let's do 47. ln of root z. All right, well, we have to remember that the square root means it's to the 1/2 power. So this equals ln of z to the 1/2 power. And using the power property, that equals 1/2 ln of z. All right, let's do one more. Let's do 58. I may have to scroll back up to show you, but let's do 58. So we're given log base 2 x to the 4th, and then root y z to the 3rd. Okay. Well, we have a product, so let's break it up like that first. So log base 2 of x to the fourth plus log base 2 of root y over z cubed. Well, with our first one, we can bring the 4 down, so that's just 4 log base 2 of x. And that one's done. But again, we're going to need to change this one around again. This is going to be log base 2 of y over z cubed to the 1/2 power. I'm going to have to do something about that 1/2 power. I can't take the quotient rule as of right now, or the quotient property, excuse me. So I can't do that because I have a difference, but I have a difference that's being raised to a different power. I need to operate the power property first. So this one's coming along for the ride for log base 2 of x plus 1/2 log base 2 of y over z cubed. And now I can break that one up using the difference. But I got to remember this 1/2. So it's 1/2 times everything in here, because I'm multiplying the 1/2 by this. This is log base 2 of y minus log base 2 of z cubed. And I'm almost done. And if you want to distribute the 1/2, you can, but I'm leaving it out. Or log base 2 of x plus 1/2 times the quantity. This one stays the same. And we can do something about this 3. So subtract 3 log base 2 of z.